Now for the fun stuff. Let's talk about the fundamental counting principle. So the fundamental counting principle says that if event A can happen in n different ways and event B can happen in m different ways, then the number of ways A and B can happen together is going to be n times m. Now that seems pretty abstract, but once we put it into use, you're going to see that it's actually quite simple and straightforward. So we know that John has 4 shirts, 5 pants, 3 hats, 2 pairs of shoes. The question is, how many outfits can John make? Okay, so event A is going to be selecting a shirt to wear. Event B is going to be selecting some pants to wear. Event C is going to be selecting a hat, and event D is going to be, well, what shoes am I going to wear? Now, we assume that John is going to wear a shirt, some pants, a hat, and a pair of shoes. Okay, so these 4 events are going to happen together because he's got to go select from each of these what to wear. So how many ways can A happen? Well, A can happen 4 ways because there are 4 shirts to choose from. The pants there are 5 of, so that then means there are 5 ways in which he can choose pants. There are 3 ways in which he can choose a hat, and there are 2 ways in which he can choose a pair of shoes. So how many ways can all of this happen together, i.e. how many outfits can he make? Well, the fundamental counting principle says 4 times 5 times 3 times 2, and then we get 4 times 5 times 3 times 2, and that's going to be 120. So he can make 120 different outfits. Now, we can use factorial notation when we arrange items that are unique where those items cannot be repeated. So this says, in how many ways can 11 soccer players run onto the pitch? Now, if we think about it as an event, there's somebody who has to run on first. And of the people who can run first, there are 11 options because there are 11 players. Then to go see who's going to run on second, well, then somebody has already run on first. So now there are only 10 people left to choose from. So this is going to be a 10. Then C, running on third, well, now there's only 9 people to choose from. And if you go on and on and on, you'll find that for the very last person, there'll just be 1 to choose from because everybody else has run onto the field. So here, if we multiply all of these events together using the fundamental counting principle, 11 times 10 times 9 all the way is going to give us 11 factorial. So here the answer is going to be 11 factorial, and for that you could just leave it in factorial notation. It's a huge number. So then it asks, what is the probability that the goalkeeper runs on first and the striker runs on last? Okay. So we know that the probability of this event is equal to the number of ways in which it can happen divided by the total number of outcomes, right? Now here the total number of outcomes is going to be 11 factorial because that's the total number of ways the 11 people can run onto the pitch. Then to figure out the probability that the goalkeeper runs on first, well, that means that this first spot is taken. Right? So now A can only happen in one way, right? The runs on first. And the striker, assuming there's only 1, he has to run on last. Okay, so now there's only 9 spots here where we can actually go and select who goes where. So running on second, we have 9 people to choose from because the goalie and the striker already know when they're going to run on. And then after that 8, and then that will go on and on and on until the last person has been selected of that 9. So here, if we multiply everything together, we'll get that it's actually 9 factorial because the 1 and the 1, anything times 1 is just 1. So we get 9 factorial over 11 factorial, right? And 9 factorial divided by 11 factorial should be 1 over 110. So 1 over 110 is the probability that the goalkeeper is going to run on first and the striker is going to run on last if we have these 11 people who run on. Okay, So then after that, we have to look at when to not factorial. And when we don't factorial is when a particular person or thing is selected to be in position A, that person or thing can still be selected to be in one of the other positions, right? So for people running onto the pitch, well, if the goalkeeper goes first, he can't go second. But here, if we select a number plate to be created by using letters, numbers, and letters, using the number 2, for example, in the first spot, isn't going to prevent you from using the number 2 in the second spot. You're allowed to use it again. Whereas, as I said, some things like the goalie running on in spot 1 or 2, well, that's just not possible. Okay, so now it asks how many number plates are possible. Now here, our number plates consist of 6 digits, right? So 2 letters, 2 numbers, and 2 letters. Okay, so in the first spot, we've got to select a letter. And of the letters, there are 26 in the alphabet. So there's 26 ways in which A can happen. The second spot, there's also going to be 26 things we can choose from, as there are, as we said, 26 letters in the alphabet. In the third and fourth spots, I'm labeling those events C and D. Well, for those, we can now actually choose 10 things because there are 10 numbers in our decimal system. And then E, F, we again get to use letters. So here, the total number of number plates is all the ways in which these 6 things, these 6 events of choosing a thing, can happen together. So that's 26 squared times 10 squared times 26 squared, and that is a huge number. So that's 4, 5, 6, 9, 7, 6. Okay, so actually 4, 5, 6, 9, 7, 600. Okay, so if you use this sort of form for number plates, then you can register almost 46 million cars with unique number plates, which I think is quite a lot. So then the probability that the number plate does not end with GP. Okay, and here we immediately think of complementary events, right? Because we heard that word not. Now, if you are to go and calculate all the ways in which it can not end with GP, there's a whole lot of ways in which that can happen. However, it's actually quite simple to find the ways in which it does end with GP. So the probability of it not ending in GP is equal to 1 minus the probability of it ending in GP. So how many ways can something end in GP? Well, the A and the B is fine. We can still use 26, 26, right? We can still use whatever numbers we want. But now this last spot is taken, or second last spot. We know it has to be a G, and we know that after that we've got to have a P. So there's only one way in which we can choose those last 2 things. And so the total number of ways this can happen is 26 squared times 10 squared. So here, to find the probability, we're going to take the 1 minus, and now the number of ways in which GP, it can end with GP, is 26 squared times 10 squared, right? And that's now got to be divided by the total number of number plates we can make, which was this 4, 5, 6, 9, 7, 600. Okay, right. So the probability that a random number plate doesn't end in GP is going to be 1 minus this 26 squared times 10 squared over that very large 45 million and something number. And so we are going to get a probability of 0.9985. Okay, so the vast majority of possible number plates are not going to end with GP.